Welcome back, focused learners. We're diving right into a brand new explainer today, and honestly, I'm super pumped about this one. We're unpacking a completely invisible, high-stakes arms race that's happening right now, deep inside your web browser. We're talking about browser fingerprinting, basically the ultimate tracking tech, versus the software built to spoof it. So let's get into it, because what your device is secretly whispering about you to the internet is fascinating, and yeah, kind of mind-blowing.
Let's just tackle the elephant in the room right off the bat. Can browser fingerprinting track you in incognito mode? You pop open private browsing and figure you're totally off the grid, right? Well, no. The answer is yes, they can absolutely still track you. Incognito deletes your cookies and your history, sure, but fingerprinting? It doesn't care about those at all. It's looking at your underlying hardware and software, things like your graphics card or the fonts you've got installed, and all that stays exactly the same no matter what browsing mode you're in.
So, here's our roadmap for this explainer. First, we'll map out the invisible digital fingerprint itself. Then, we'll rank the top fingerprinting APIs, take a look at the ultimate lie detector, see exactly how anti-detect browsers actually defend against this stuff, and finally, we'll peek into the future of fingerprinting.
Okay, part 1, the invisible digital fingerprint. Let's set the stage and look at how your own hardware is basically betraying your identity.
There is a massive shift happening right now in web tracking. We're moving away from old-school cookies, those explicit physical text files dropped on your device that you can easily clear or block. Fingerprints are a whole different beast. They're invisible, they're probabilistic, they don't leave a single file on your machine. Instead, they just sit there and silently scoop up 50 or more different data points about your browser and OS. Then, they use all that to mathematically deduce that you are, well, you.
And you might be wondering, just how effective is that math? Well, the Electronic Frontier Foundation ran this project called Panopticlick, and they found the average browser fingerprint contains 18 to 22 bits of identifying info. To put that into perspective, out of millions of users, your specific combo of seemingly random device settings makes your digital profile insanely unique. You're literally 1 in a million, and you didn't even have to log into anything.
So where is all this data actually coming from? The short answer? Everywhere. These trackers are yanking your screen resolution from the Screen API. They're counting your CPU cores through the Navigator API. They're checking your fonts, and get this, they're even measuring exactly how fast your computer runs specific operations using timing APIs. Every little component, down to your battery, is quietly leaking pieces of the puzzle. It's just a massive arsenal they've got.
Moving on to part 2, top fingerprinting APIs ranked. Let's look at the actual weapons the hunters are using out there in the wild.
When we compare the top tools, there's a very clear hierarchy. Right at the top, the apex predators, you've got commercial giants like FingerprintJS Pro, which has insane accuracy and catches spoofing attempts. Then you step down to open source libraries hitting maybe 40 to 60% accuracy. Below that, native browser APIs like Canvas, and finally, those deep server-side trackers like JA3 and JA4. Let's break down the heavy hitters here.
Look at that 99.5% accuracy rate for a second. That's FingerprintJS Pro. It is the absolute industry standard, running on over 12,000 websites right now. And it hits that near-perfect identification rate because it doesn't just look at client-side data, it combines those with server-side signals like IP analysis and bot detection. Trying to hide from this thing is definitely no joke.
But how do the native APIs physically identify you? Take the Canvas API. The tracker basically commands your browser to whip up a completely invisible canvas. Then it says, hey, draw this specific text and these geometric shapes with some complex gradients. Now, because every graphics card, driver, and OS renders pixels just a tiny microscopic bit differently, the raw pixel data they extract from that drawing is utterly unique to your machine. They hash that visual data and boom, they've got your custom visual signature. Then you have WebGL fingerprinting, which goes way deeper than Canvas. It's not just drawing 2D shapes, it's interacting at your GPU. It wants to know your exact GPU vendor, your specific rendering capabilities, even the 3D shader formats you support. Then it renders a full 3D scene. So even if you and a friend buy the exact same model of graphics card, if your driver versions are even slightly off from each other, WebGL will catch those subtle rendering differences. And guys, it's not just visual, it's audio too. The AudioContext API actually forces your browser to generate a silent audio signal using an oscillator. It runs that signal through a digital compressor, extracts the audio buffer, and hashes the samples. Because of tiny hardware quirks in your machine's audio processing stack,
It creates a completely unique acoustic signature. Basically, your computer literally sounds different to a tracker than mine does. Crazy, right?
But honestly, the most terrifying one is server-side TLS, or JA3 fingerprinting. This captures the cryptographic handshake between your browser and the website itself. And here's the kicker. This happens instantly, before a single line of web code or JavaScript even bothers to load, which means all those standard privacy extensions you've got installed, completely useless against this. The tracking happens before the extension can even boot up. All right, Section 3, the ultimate lie detector. So what happens when privacy tools actually try to fake all this data?
Enter CreepJS. If trackers are the hunters, CreepJS is the ruthless police interrogators sitting across the table. It's an open-source tool built entirely to detect if you're faking your fingerprint. And it does it by hunting for contradictions. Let's say you try to spoof your user agent to claim you're on a mobile phone, but your screen API says you've got a massive desktop monitor resolution. CreepJS instantly flags the lie. It cross-references absolutely everything to make sure the story your browser is telling actually makes logical sense.
Which brings us to Section 4, how anti-detect browsers defend. If you can't just block these APIs without completely breaking the internet, how do privacy tools like Send.win actually protect us?
The secret sauce is spoofing, but highly calculated spoofing. Look at Canvas fingerprinting again. A rookie defense would just be throwing random noise into the pixel data to confuse the tracker. But trackers are smart. They look for random noise. If your output changes every millisecond, they immediately know you're hiding something. So advanced anti-detect browsers use deterministic, seeded noise. They modify the pixel output so it's totally fake, sure, but it is remarkably consistent. It lies, but it tells the exact same lie every single time.
It's the exact same game with WebGL. You can't just block it, or websites will straight up crash. Instead, an anti-detect browser swaps out your real GPU parameters with plausible real-world profiles pulled from a massive database. It tells the tracker, yeah, I've got a standard NVIDIA card, and then it injects deterministic noise so the rendering flawlessly matches that specific fake card. And what about that unblockable server-side TLS tracking we talked about? To beat that, anti-detect browsers literally have to dig into and modify the underlying open-source Chromium code. They alter the core TLS behavior so that the very first cryptographic handshake perfectly matches the fake platform identity they just built for you.
And the ultimate defense mechanism that holds this entire house of cards together? Consistency cross-validation. This means generating a complete device profile where every single parameter aligns perfectly with zero contradictions. Remember CreepJS? To survive that intense audit, your fake Canvas data, your fake GPU, your fake audio signature, and your fake screen size all have to tell one tight, coherent story of a device that could realistically exist out there in the real world.
Finally, Section 5, the future of fingerprinting. What does the next phase of this endless digital arms race actually look like?
Well, the landscape is shifting incredibly fast. You've got Google's Privacy Sandbox trying to lock down some APIs, pivoting away from individual hardware tracking and moving toward broad topics of interest. But obviously, trackers are adapting. We're seeing a terrifying rise in machine learning-based detection that builds a behavioral fingerprint. It analyzes the exact cadence of your typing and the micro movements of your mouse. Plus, we're staring down hardware attestation, actual cryptographic proof verifying your specific physical machine.
Our source material really hits the nail on the head with this quote. Browser fingerprinting is in a constant arms race between identification systems and privacy tools. It's so true. The minute a new detection method drops, a new spoofing method gets engineered to bypass it. It is just this never-ending, high-stakes game of digital cat and mouse. Which leaves us with a pretty provocative final thought to chew on today. As hardware attestation becomes the new standard, and AI learns to identify us literally just by the way we scroll our mouse, will software-based spoofing eventually become completely obsolete? Can true digital anonymity actually survive the next decade of the web? Thanks for digging into this explainer with me today, and keep questioning the tech behind your screens.